Okay, so we're talking about the chain rule, or it's also called the function of function rule, and I'll tell you why. I think I even prefer the word function of function because it explains it very well. Now, what is the chain rule and what's the function of function rule? Let me give it a scenario. If you're given a value y is equal to, let's say, is equal to 2x, and we have to differentiate this, we know that dy dx will be equal to what? 2, right? Yeah. But what if your y is equal to, let's say it is equal to um, 2x raised to the power of, let's say, okay, let's say it is equal to 2x raised to the power of, let's say, 2. Then our dy dx is equal to what? You open it up. When you open this bracket, you have it as what? 4x squared, right? So our dy dx will be what? 8x, right? Okay, then let's finally move on. Then what if our y is equal to, we have it as 2x plus 1 raised to the power of 2. Then our dy dx will be equal to what? Because the first thing you first have to do is to first open this bracket, right? And then you solve it. So when we open this bracket, if we were to open this bracket, let me move my screen over to the other side, sorry. If we were to open this bracket, we'll have that we'll be having so we'll be having 2x opening 2x plus 1, and also plus 1 opening 2x plus 1. So what do we have? We have 4x squared plus 2x plus 2x plus 1, and that is actually 4x squared plus 4x plus 1, right? Now this is what we will have. So therefore this is what we'll differentiate. So when we differentiate this particular value, when we find the dy dx of this value, we'll be having what? We'll be having 8x plus 4, right? So actually our final answer is meant to be what? 8x plus 4. But then, what if you were given this particular question again as y is equal to 2x plus 1, and then you were given 1 over 2? Wow. You ask yourself, sir, but I don't know how to open a bracket carrying raised to the power 1 over 2. Or, what if it's actually 2x plus 1 raised to the power of, let's say, 92? No, you were like, I don't know how to, this one will be too large to open. So in cases like that's when you employ the function of function rule. The function of function rule is whereby you have a function that you need to differentiate, but it is inside another function. So what is the function you need to differentiate? It is actually this 2x plus 1, but it is inside another function, which is what? Raised to the power of 1 over 2. So that's what we call the function of a function. It's actually found from what they call the composite function, which is when you have a function inside another function denoted by this f of g, or you can call it as what? F of x of, so it as what? F of x of g of x, or you can write it again like this: f of g of x. So but don't worry, I know you've not entered into this stage yet, so maybe when we enter into functions inside in major, then we'll discuss about this very well. So let me talk about my chain rule now in detail. Let's scroll down and we'll discuss our chain rule in detail. So what's our chain rule? Let's start again. Chain rule. What's our chain rule, or our function of function rule? In our function of function rule, as I've explained, is when you have a function inside another function. So what does it mean? How do you solve for when you have something like that, and it will be very easy to solve it? It's going to be this formula. Our dy dx, whenever it is for function of function, it will be what? Remember, let's show you. Remember when I gave you that question where I had y is equal to 2x plus 1, and we have it raised to power what? 2, right? Now remember our final answer was what? I think let's go back to our screen and see what was our final answer. Our final answer we got was 8x plus 4. Yes, so let's go back and I will now prove to you how we can get 8x plus 4 without going through all the long journey we just did. So how do we get 8x plus 4 again? Is by taking this separately, taking these two functions separately. So let me say that this is my first function, which is f of, which is let's call this first function, let's call a u this first function. So let our u be our 2x plus 1, and then let our v be the other function. Let our v then be our u. Since our u is the one that is inside it, u raised to the power of 2. So if our u is 2x plus 1, then our v will then be what? U raised to the power 2, right? So what's the first thing we first do? Let's differentiate our u. So if we differentiate our u prime, it will give us what? It will give us just 2, right? To give us just 2, because when you take the differentiation of u, we'll have what? 2. And then if we differentiate our u square, what do we have? We have what? 2u, right? Remember how to differentiate? You just take the 2 over to this side, subtract 1, so it will be 2u. Then when we multiply these two together, when we bring them together, when we say our y equal to 2u times 2, what do we have? We have 4u. But what's our u? Our u is what? 2x plus 1. So it's like saying 4 bracket 2x plus 1. If I open 2 with my bracket, it will be what? 4 times 2, 8x plus what? 4. And that is why we got our answer here as what? 8x plus 4. So that's what happens when you work with chain rule, function of function rule. So in essence, I can bring out this formula I've used to solve this by writing that whenever you have the dy dx of any value and you have two functions in that value, maybe more than two functions, but let's work with two functions, the formula will be what? It will be the differentiation of dy over du. So we have our u first multiplying what? Du over dx. So that's how we solve for our chain rule. Now let me give myself a question now, like the one I gave. I said if y is equal to 2x plus 1 raised to the power of what? 1 over 2. How do we solve for this particular case? Now I can say that let my u be equal to what? 2x plus 1, right? And therefore my y is equal to what? U raised to the power of 1 over 2. In the other case I used v here, but let me now use my y since I'm now working my chain rule. So my y is equal to what? U raised to the power of what? 1 over 2. So according to my dy dx, I'll first do what? Dy du. I'll first find the dy du. That's if I have I'll first find my dy in respect to du. Then I also find my what? Du. That's my du in respect to what? Dx. So in respect to dx. So what is my dy in respect to du? So this is my dy du. It will be what? Here will be what? You subtract minus 1 and bring back your half. So it will be what? 1 over 2 u raised to the power of what? When you subtract, it will be 1 over 2 minus 1, right? That is like saying 1 over 2 u raised to the power of what? Minus 1 over 2, right? Then what about this one? In this case, we find our du over dx, right? So du over dx will be what? We'll be having just 2. So bringing it into this one, dy du give us what? 1 over 2 u raised to the power of what? Minus 1 over 2 times 2. So when we multiply, I know that 2 we cancel out 2 here. Is that not so? So we have just what? U raised to the power of minus 1 over 2 left. And what is our u raised to the power of minus 1 over 2? Is 1 over u raised to the power of 1 over 2, right? So I can open my u. What is the value of my u? My u is what? 2x plus 1. So that's 1 over 2x plus 1 bracket 1 over 2. Or I can write this in essence to be what? To be equal to 1 over 2x plus 1 square root. Because I know that 1 over 2 means square root of 2x plus 1. So is that okay? Now that is one way to solve questions using chain rule. Let's look for more questions to solve in our chain rule. Let's for more questions. Let me move my board. I think I have questions gathered in my book, a lot of them. Okay, look at this one here. I have when we are given y is equal to 4 over the square root of 1 minus 2x, and we're asked to solve this. So how do we solve this again? First of all, let's find our u. Our u will always be okay. Before I find my u, let me put my y in perspective. So y is equal to 4 bracket, take away this square root and put it in powers. 4 bracket what? 1 minus 2x raised to the power of what? Minus 1 over 2. I believe you know that because this was under, so it's going to carry a minus 1 over 2. So now I can now find my u. What's my u? My u, let me use a different color for that. my u is equal to what? I know it's going to be equal to 1 minus 2x. So 1 minus 2x. And then therefore my y is equal to what? 4u, because it's now my u raised to the power of what? Minus 1 over 2, right? So let's solve again. So what is my du dx? So for my du dx, let me use a different color to do that. So for my du dx, I have it as what? Differentiating this, what do we have? I have minus 2 as the answer. I'm sure you know how to differentiate by now. So then for my dy du, this is where we'll do a little bit of more work. So it will be what? Subtracting, it will be minus 1 over 2 come over the other side to be what? Minus 1 over 2 multiplying 4 u raised to the power of minus 1 over 2 minus 1, right? According to our formula. So we know that 2 can cancel out 4 here, and then we have just what? Minus 2 remaining, u raised to the power of what? Minus 1 over 2 minus 1 will give us minus 3 over 2. And so we have this as equal to what? I can, okay, let me just leave it like this first of all, and then bring it into my new solving. So our dy dx, which is equal to, is meant to be equal to what? Dy du multiplying du dx. So what is our dy du? Our dy du is what? Minus 2u raised to the power minus 3 over 2. So we have minus 2u raised to the power minus 3 over 2. And then multiplying what? Multiplying our du dx, which is what? Minus 2. So we have minus 2 multiplying minus 2 here. So when minus 2 multiplies minus 2, we have minus 4. U raised to the power minus 3 over 2. So what's u raised to the power minus 3 over 2? This value, what is it? It is what? 1 over, because remember indices, minus 4 over, we have it as u raised to the power 3 over 2. Then we can still go further by checking what is u raised to the power 3 over 2. It's taking what? The cube root, it's taking the square root. Remember, the square root of u raised to the power of what? 3. And then this is minus 4. So here's what? Minus 4. What is our value of our u? Our u is what? 1 minus 2x. So we have it as what? 1 minus 2x square root, and everything is what? Raised to the power of what? 3. So this is the final answer for dy dx. So it is minus 4 over square root of what? 1 minus 2x raised to the power of what? 3. So let's take one last question, and I'll call it a day for this, for the chain rule. And okay, so we have a question here again. I'm looking for something that is maybe more tough than what we've done. Okay, yes, I think I like this one. Okay, no, it's actually very easy. Now let's look at this question here. This one looks a little bit tough. We have this as y is equal to the cube root of what? 2x raised to the power of 3 minus x raised to the power of 2. Now remember, I told you the first thing to first do was transform them to their indices form. So transforming this to in the indices form will be what? 2x raised to the power of 3 minus x raised to the power of 2 raised to the power of what? We have this as 1 over 3 according to indices, fractional index law. Now therefore, solving this particular case, we know that our u, we bring out our u. What's our u? Our u will be what? 2x raised to the power of 3 minus x raised to the power of 2. Then our y is equal to u raised to the power of what? 1 over 3. So here we have our du dx. What's our du dx? Du dx will be what? It will be, solving this one, it will be 3 times 2 x raised to the power of what? 3 minus 1 will be what? 2. Minus, here will be 2x raised to the power of 1, because when we say 2 minus 1 is 1. So definitely our final answer is what? 6x squared minus 2x. Then what about our y? For our y, our dy du, since it is in respect to u, our dy du will be giving us what? Minus 1 here, and then bring our 1 over 3 down to the base. So that will be, let me see different color, that will be 1 over 3 u raised to the power of what? 1 over 3 minus 1. And that is equal to what? 1 over 3 u raised power of what? 2 over 3. I believe so. So let's check it out. We have that 1 over 3 minusing 1 over 1. That would be like the LCM is 3. So we have here as 1 minus 3, and that's minus 2 over 3. Okay, that's actually a minus 2 over 3. So that's a minus 2 over 3. So finally, I can now say that my dy dx according to the formula is equal to dy du multiplying du dx. So that means that for our value, what's our dy du is what we have it as 1 over 3 u raised power what minus 2 over 3, right? Multiplying what's our du dx. Let's check our answer. We had it as 3x 3 we had that 6x squared minus 2x, so that's 6, let's put in brackets 6x squared minus 2x in brackets. So opening this, we have 6x squared minus 2x over 3 multiplying what u raised power what minus 2 over 3. So this is closing. Then what happens next? What is my value of my u? My value of u, and my value of u, remember this is minus, so before I do that, let me first do this. That's 6x squared minus 2x over 3 times what the value of my u is like this. That's from our minus sign. Index law will tell us we'll take this over, so yes, u raised power what 2 over 3. So I can proceed in solving this. Let me bring this down as what here is 6x squared minus 2x over 3 times what 1 over, for our u raised power 2, our u, what's the value of our u? The value of our u was actually gotten to be, let's look at the value again, 2x raised power 3, so it was 2x raised power 3 minus x squared. So but remember, it is what u raised power 2 over 3, so that's, we have this as what 2 over 3. That's for the remember I'm looking for dy dx. So our dy dx continues. We can continue this as saying 6x squared minus 2x over 3. Remember, what is this? It will be the cube roots. So if I want to, I can put it as what the cube roots of what 2x raised to power 3. So let me put that minus x squared, and then remember this is carrying raised to power 2, so I can put this all raised to power 2. So here is all raised to the power of what 2, and that is my final answer. So this is how you solve it, and it's actually very easy. There's nothing much, there's no really serious anything much hard in solving function or function. You just take it step by step so that you won't confuse yourself. So next time we'll come again, we'll enter into a new rule. I think we'll enter into the product rule. So see you in the next video. Thank you.